What is up, Math Made Easy fans? Today we have another really epic video for you guys. We're going to be doing some geometry, and in fact this is problem number 22 of the AMC 8 of 2018. I'm going to be doing some AMC 8 until like November 12th or 18th. I don't know which one, when the test will happen. And then I'll get into some AMC 10 stuff when I do my AMC videos. But make sure to comment down below topics you'd like for a future video. Now, I got something special to show y'all. I got some new markers, right? We have black, red, blue, and green. So which one would you like to see in the future video? Today I'm just going to use black. And I got this, and this eraser came with it. And like, because whenever I've seen these eraser things, they've been all like worn. I mean, it comes like in a nice, like fluffy little gray thing. Like, I think that's so cool. I didn't know it was gray. I thought it was black. So you learn something new every day, and you guys are gonna learn some stuff today, hopefully, with this episode of Math Made Easy. So let's get started. Point E is the midpoint of side CD in square ABCD, and BE meets the diagonal AC at F. The area of quadrilateral AFED is 45. What is the area of ABCD? Okay, so, and this diagram came with a problem. So you can see 45 here. This is kind of what's going on here. E is the midpoint of DC, and then this is F, right? So basically, from this, we're going to get to see this whole thing's area. So, let's get started. We know that this AC is going to split the square in half, right? In half perfectly, actually. So, we know that ADC triangle and ABC triangle are going to be the exact same area. So, we have 45 plus, let's just call this X as this. So, we'll multiply that by 2, we'll get 90 plus 2X as what our ABCD will equal. And we'll solve for that later once we learn a little bit more about this thing, what's going on. Okay, so what else do I notice about this? Well, I noticed we got some similar triangles going on, right? Look at FEC and then look at ABF. I mean, that looks pretty similar to me, right? And we can actually prove they are similar by AA similarity. We got, of course, these are vertical angles, so they're always going to be the same. And then by the, I think this one is the interior angles theorem. You know all those theorems with those parallel lines. I should cover that on the channel. I forgot their names, but by those theorems, these two have to be the same. And angle-angle similarity says that means these have to be equivalent. We also know they're going to be in a 4-to-1 area ratio because this is half. EC is half of AB because ABCD is a square. It probably doesn't look like that in my drawing, but that is the intended purpose. So we would square that 2-to-1 ratio to get a 4-to-1 ratio. So here we can see that, in fact, 3/4 of this figure equals 45 plus 4x, right? Because we know this cuts off 1/4 of it. So we have 3/4 equals 45 plus 4x, right? And you might turn to multiply this by 3/4, but we're going to actually have to divide this by 3/4. So when we divide, remember, just flip these from my dividing fractions video. So we will get 60. We'll just get 60 plus, this is going to be a little bit funky, but we're going to have, I should do improper fractions. Now, I don't like mixed numbers, and your math teacher probably doesn't either. So, we're going to write an improper fraction here. And we actually know that, hey, we just know that this equals 90 plus 2x. We'll subtract 60s from both sides, and we'll subtract 2x from both sides. So now we'll get 10x, or 10 over 3x, right, equals 30. What I'm going to want to do is just get rid of this fraction. I don't like this fraction here. I'm going to multiply both sides by 3. Multiplying by 3, we will get 10x equals 90. So then that would mean x equals 9, right? Epic. So plug in x equals 9 to this, and we get 108, which is in fact answer B of the problem. So this is number 22, once again, of the 2018 AMC. Thank you very much for watching, my dear Math Made Easy fans. But for now, I'll see you in the next one.